Okay, here are some problems for Chapter 5, Section 3. By now you should have gone through the chapter, copied the yellow boxes, and attempted the pencil problems. Okay, let's go through here. For number 13, they want you to evaluate tan of 45 degrees. So what we're going to do is make a coterminal angle. Since it's periodic, we can subtract 180. Tan has a period of pi. Tan of theta has a period of pi. That means its values are the same every 180 degrees. Since this is such a large number, I'm going to go ahead and subtract 2 pi's. So I'm going to subtract 360. And I get 45. Or you can look at it this way: tan of 180 plus 180 plus 45 is really the tan of 405 degrees. I tend to subtract. You can do it this way. So tan of 45 degrees equals 1. You could say that 405 degrees is coterminal with 45 degrees. Now, for secant, what I'm going to go ahead and do is just subtract 2 pi. I can tell right away this is bigger than 2 pi, so that it's bigger than 360. So if I subtract 2 pi, I'm really taking 17 pi over 4 minus, I need a 4 here, so it's going to be 8 pi over 4. That gives me 9 pi over 4. However, again, this is still bigger than 2 pi or bigger than 360, so I'm going to subtract another 8 pi over 4, and I get pi over 4. Then all you have to do is look for secant of pi over 4, and secant of pi over 4 equals root 2. Alright, now we're going to look at our quadrants, Cartesian coordinate system. We know in our Cartesian coordinate system, in quadrant 1, x is positive, y is positive. In quadrant 2, x is negative, y is positive, and it goes around. You should have learned this, middle school. But we also know that sine of theta equals y over r, in which if r is 1, then sine of theta just equals y. Similarly, cosine of theta equals x. So in quadrant 1, sine is positive, cosine is your x. So we really have cosine is your x, and sine is your y. Everything is positive. All your 6 trig ratios are positive in quadrant 1. So we're going to put all of them. Now in quadrant 2, cosine is negative and sine is positive. So sine is positive. We already went over this in the previous section. If sine is positive, then so is its reciprocal if cosecant is positive. Everything else is negative. So all of the other functions are negative. In quadrant 3, the only positive angles are tan is positive and cotan is positive. Everything else is negative. And in quadrant 4, cosine is positive, therefore secant is positive. That is 0. Secant is positive, all others are negative. Some students remember this as all students take calculus. So quadrant 1, all the trig ratios are positive. In quadrant 2, only the sine and therefore the cosecant's positive. In quadrant 3, your tan and therefore your cotan is positive. And in quadrant 4, your cosine and therefore your secant is positive. So this is for your positive angles. So if I'm asking you if sine of theta is negative and tan of theta is negative, what quadrant are we in? Well, we know sine is our y portion, and our y portion is right here. So what quadrant is sine negative but tan positive? Or negative, tan is negative. So that would be in quadrant 4. Now a lot of students ask me, why is tan negative? So let's go over that real quick. I'm going to stick it in here. Tan and cotan is positive in quadrant 3 and of course 1, because a positive divided by a positive is a positive. But we're in quadrant 3, we have tan of theta equals y over x, which is a negative over a negative, and that equals a positive. Okay, we have to find the remaining trig functions, given that sine of theta is negative 5 over 13, and cosine of theta is 12 over 13. If you notice here that sine is y over r, and cosine is x over r, then we have our ordered pair is 12, negative 5. This is our xy. And our r is 13. So all you have to do, you have sine and cosine. Now we just need tan theta, which is y over x, which is just going to be negative 5 over 12. We also need cosecant, which is r over y, which is, you're flipping those two, which is going to be negative 13 over 5. Secant, you just flip these two, so that's going to be 13 over 12. And then cotan, you just flip these two. So cotan of theta would give you negative 12 over 5. And here's another way to present it. They give you cosine of theta is equal to negative 3 over 5. And theta is in quadrant 3. So we need to find all the other ratios. If we're in quadrant 3, I want to know what sine of theta is. I know this is x and this is r. So my x is negative 3. I don't know what y is. And my r is 5. R always has to be positive. So r equals 5. It's a radius. Radius can't be negative. Now since I know my triples, and I don't have to use the Pythagorean theorem, I know that my y is 4. The only question I have is if we're in quadrant 3, is y positive or negative in quadrant 3? It's negative. So I'm going to go to put a negative here, and I'm going to, sine is going to be negative 4 over 5. Tan, notice tan, we talked about this earlier, is y over x. So this is going to be negative 4 over negative 3. Two negatives make a positive, so that's 4 over 3. That's why in quadrant 3, tan and cotan are always positive. Now, so cotan, let's do that. Cotan's going to be positive, and we just the reciprocal, so that's 3 over 4. Now all we have to do for cosine, the reciprocal of cosine is going to be negative 5 over 3. And the reciprocal of sine is cosecant, which is going to be negative 5 over 4. And no, I'm not putting the negative with the radius. I'm just making negative for the whole expression. Okay, the radius, this is just a value at this point. Okay, we're determining even and odd properties. Like I said, by now you've gotten used to these videos, so I'm going a little faster. With the sine is a odd property, so since it's odd, I can rewrite this as negative sine of 60. Now, when you know what sine of 60 is, then you just take the negative value of that. So sine of 60 is root 3 over 2. And you take the negative of that. So the answer of negative sine over 60 is negative root 3 over 2. Now let's look at this a little closer. When you're talking about negative 60, that means we're going to draw our initial side is the x-axis. We're going to go counterclockwise and go to 60. There's my terminal side, and our theta is negative 60. Alright, that means sine at 60 is positive, but in quadrant 4, sine is negative. That's why this is a odd property. Because we're talking about quadrant 1 and quadrant 4. However, it's negative 60. You could have also added 360 to this, and if you found a coterminal angle, you could have done sine of 330. Looked on your unit chart, and you would have got this. So sometimes it's just easier to use even and odd properties, especially with cosine. So for cosine that is even. We'll talk more about this when we do graphing. So that means I basically can just take out the negative and call it cosine of 60. Cosine of 60 is 1/2. Let's look at the way the graph looks. This is the initial side here, 60 degrees. I don't like how that turned out. So 60 is about here. So this is theta equals 60. Negative 60 is here. So if I went counterclockwise, negative 60. Okay, negative 60, the reference angle for negative 60 is 60. Since cosine is positive in quadrant 1 and 4, we can just take out the negative here and not worry about looking at the unit chart. So if you know what quadrant 1 is for cosine, you can just take it out and you have your value. You need to think about this a little more. We'll do more of these in class. Alright, 77 and 79 are very easy if you know your fundamental identities. In this case, we have sine squared of theta plus cosine, we'll use this a lot, by the way, equals 1. So as long as my thetas are the same, which in this case they are, if they're not, it's a different story, but since they're the same, this equals 1. Okay, we're going to use the fact that cosecant, we're going to use sine of 80 degrees times, we're going to use the fact that cosecant really is just 1 over sine. That's part of your fundamental identities. So what we get is sine of 80 over sine of 80 degrees, and this equals 1. And that is all.